This is a very short video in which we're going to talk about compound measurements. Now, compound measurements include distance, area, volume, weight. They're all quantitative measurements, okay? So those are not compound measurements. They measure the quantity of something, how long it is, how high in the amount of space it may occupy. The volume and weight is used to measure the amount of a substance. A compound measurement measures two or more properties and compares them to each other. Okay, so that's the biggest difference. Quantitative measurements are measuring one thing. Compound measurements are measuring two or more properties and comparing them to each other. It's useful to compare the weight and volume of substances when we need to know how much you have. Three comparisons are used for this purpose. You have density, you have specific volume, you have specific gravity. Density compares weight to volume. Specific volume compares volume to weight. Specific gravity compares the density of a substance to the density of air or water. Pressure is a compound measurement. It compares force to the area supporting the force. The pressure on any surface can be determined by dividing the total amount of applied force by the area. Let me repeat that. The pressure on any surface can be determined by dividing the total amount of applied force by the area. For an example, an object that weighs 100 pounds and has a base of 100 square inches will exert a force of 1 pound per square inch. This is abbreviated of 1 psi. 100 pounds over 100 square inches, divide those two numbers, it's 1 psi. If the object weighed 100 pounds but had a base of 50 square inches, again, you divide 100 by 50, the answer is 2, because the same weight is supported by a smaller area. To calculate the pressure, you always divide the force by the area. In air conditioning, pressure is most commonly measured in psi. And I want to add to that, that's in like refrigerant pressures. If you're talking duct pressures, it's measured in water column, and we'll get to that in a little bit. Air conditioners are dynamic devices. Many performance characteristics that technicians need to measure are moving. Measuring something that's moving is done by rate. A rate measurement is a compound measure that compares quantity with time. In air conditioning, airflow, water flow, and even a system's heating or cooling capacity are stated as a rate. The airflow through an air conditioner is a perfect example. The output of a fan is measured in cubic feet per minute, which describes the volume of air in a cubic feet that the fan moves every minute. A common rate measurement for water flow is gallons per minute. Describes the number of gallons that a pump can move in a minute. System capacity is stated as rate of heat flow in BTUs per hour. This is the amount of heat produced or rejected in 1 hour of operation. There's two common electrical measurements that are also rate, amperage and watts. Amperage measures the flow of electrons. An amp is the flow of 1 coulomb of electrical charge per second. So again, your meter measures rates. Watts measures the rate of electrical power. A watt is the transfer of electrical energy at a rate of 1 joule per second. Rate measurements require quantity measurement and time measurement. When measuring water flow, gallons represents the quantity, while minutes or hours represents the time. The number of gallons collected in a minute or hour represents the rate in gallons per minute or gallons per hour. Airflow is a little different. We cannot collect air to check for the rate of airflow, but we can check the speed of the air and use it to determine the amount of airflow. Airspeed or velocity is measured in feet per minute. Feet per minute describes how far air will travel in a 1 minute period. To determine the volume of air, multiply the velocity of air by the area of the hole it's leaving. For example, air traveling at a rate of 100 feet per minute through a 1 square foot opening will make a column of air with a volume of 100 cubic feet in 1 minute. Okay, another example. Calculate the airflow leaving a 24 by 36 inch hole at a velocity of 50 FPM, which is feet per minute. The area of the hole is calculated multiplying 24 by 36. That's 864 square inches. Now you have to convert the square inches to feet by dividing by 144. Remember, we're dealing with feet. Anytime we move square inches to feet, I divide it by 144. So 864 divided by 144 is 6 square feet. So the airflow in CFM is calculated by 50 feet per minute times 6 square feet is 300 CFM. So again, take your velocity reading, take the area of the hole, which is length times height, two-dimensional or single-dimensional measurement here. So you're getting area, length times height, 24 by 36 is 864 square inches. Now I have to take that square inches, divide it by 144 to get my square feet. We get 6 square feet. The airflow in CFM is calculated by 50 feet per minute times 6 square feet, 300 CFM. Folks, that is something that when you're in the field, you do need to know how to do. Heat flow, okay, is the quantity measured in British thermal units. A BTU is defined as the amount of heat required to raise 1 pound of water 1 degree Fahrenheit at atmospheric pressure. BTUs are calculated by multiplying the weight of the water by the temperature change in degrees Fahrenheit. For example, raising 100 pound of water 50 degrees would require 5,000 BTUs. So 100 times 50 is 5,000. BTUs are a quantity, not a rate. The amount of time required to raise the water temperature is also needed to specify the rate. If this is accomplished over a period of an hour, the rate would be 5,000 BTUs per hour. If the same amount of temperature rise took 2 hours, the rate would be 5,000 BTU over 2 hours for 2,500 BTUs per hour. So again, in this video, we talked about the compound measurements. Okay, we talked about rates. We talked about feet per minute. I gave you a calculation for airflow coming out of a duct or going through a duct. You take the area of the duct, put it into feet, and then multiply the feet per minute times the area, the square foot of the duct area. Okay, that's a pretty important measurement. That's one you're always going to use.